Hi everybody, Eric the Car Guy here again with
ScannerDanner,
the famous ScannerDanner. Did I interrupt you? I am so sorry.
It's okay.
I am so sorry if I interrupted you.
I promise I won't say yes and and while you're talking.
So what we have here today is, what is this? Some kind of truck?
It's white.
It's a white. Today we have a white truck that is not starting. Is that the deal with it?
Yep.
So how about this time, since we have a no start situation with something like this, how about this time, instead of using like expensive scanners that like the normal person doesn't have, and we just use like regular equipment to try to figure out what's going on with this
I think that's a great idea.
Because he's got like knowledge inside his brain that we can like ooze out onto the engine block.
You say so.
I'm just, you know.
It is an F-150, by the way.
It's an F-150, looks like about
fact,
a 92, 3, perhaps. We'll find out here in a minute. Get right back.
It is a 96.
Oh!
F-150.
Eric the Car Guy is so off on that. But you know what? All they did was change the headlights and taillights. Whatever. Let's figure this out.
Okay.
All right, now I suppose step one would be to verify the complaint. So let's try and start this bad boy. And it does not start. So what would be the next step, do you think?
It's your call. I mean, we could go spark, fuel, compression, plugged exhaust.
We need all those things in order to get the thing to run. And personally, I think the easiest thing to check is for spark. So can we start with that?
I like that. It's easy to do on this one.
You've got a spark tester around?
I do.
It's not hooked up to a lab scope, is it?
No, it's not.
All right, awesome.
On this one, certainly checking spark is an easy step. It's a external coil.
What is this, like a 300 straight 6?
This is a 300 straight 6, yes it is. And I don't know if you can see that coil or not in the picture. Maybe I get a little light on that. That coil is right there in that location.
Covered with oil in it.
Yes.
Yes.
So nice and easy to get to. Certainly on some cars, maybe we don't start with checking spark just because it might be a little bit more difficult.
Well, yeah, and some of them have like coil on plug and that kind of thing. Well, even with a coil on plug, you can pull a plug or something out. But this one, we're lucky to have a distributor, and we can just throw a little, you know, auto parts store spark tester
That's like
on it.
Yep, $10
Yeah.
spark tester. I think I got that probably 20 years ago off of one of the tool trucks that would come to our garages, you know.
And you can actually crank that one in and out to sort of check the kV output on it.
Yes, and actually I usually like a 20,000 kV just because a coil should be able to produce at least 20,000. I mean, that would be the minimum you'd want to see. So I have it set, there's actually a scale in here. I have it set around a 20,000ths gap, and I'm just going straight to ground and see if we have spark.
So you're just like right there on the throttle body?
Yeah,
so
just
if we do get a spark, we're going to have some nice fuel ignition?
No, that's a good point. I mean, we're far enough away from the injectors that, you know, I don't think you'd necessarily want to go to a fuel rail, but certainly I've seen spark plug wires arc on a fuel rail before. And
Oh, we got a fire extinguisher around here somewhere, don't we?
we do, right behind you, actually, on the wall.
We are working safely.
Yes, we are. Let's crank and see if we have spark.
All right, you got no spark, man. All right, so we found out we had no spark, which we were really lucky since that was the first thing we would check. So it could also be a situation where we didn't have fuel, or there was some kind of mechanical problem with the engine, it was out of time, didn't have the proper compression, blah, blah, blah. But we know we don't have spark. So step two, what would you do next?
Well, step two, I think, would be, do we have an input problem, or do we have a coil problem, or do we have an igniter, in this case, ignition module problem? I think those are really what I'm thinking about.
So primary side or secondary side? Is that what you're trying to make the determination for?
Yeah,
here?
I think that would be the primary side, and I mean, you know me with my scope. Of course, I want to break out my scope.
You can't in this video.
I can't in this video, and I'm
you.
okay with that because, truthfully, my first 6 years in the field or 5 years in the field, I really didn't have a scope, so I had to do things like this.
All right. Well, what do we do next?
Well, I think one of the things that helps to have a flow chart, and I know we don't all have a flow chart, but I just want to talk about the Ford flow chart for a second. What they tell you to do on this system with the TFI ignition is to check for a crank signal, which in this case is the distributor pickup, if you want to call it. It's a Hall effect. So you check for the signal, and what you do is you look for 4 to 5 volts while you're cranking. That is a Ford released flow chart for this system. For all of these TFI distributor systems where they use a pickup in the distributor, 4 to 5 volts cranking. With a little bit of homework on that signal, it is actually a square wave, and it's a 0 to 10 volt square wave. So the thing about that is they give you that number and you don't realize what you're looking at is an average of a square wave that's occurring. And so really, if you know that, it helps to look at your voltmeter and say, okay, if I have 4 to 5 volts, then I can be pretty confident that I have a 0 to 10 volt square wave taking place here. A voltmeter reads an average, and it's something people don't understand sometimes.
Right, because you got all Einstein on me, and they're talking about waveforms and TFIs and all that kind of stuff. And I have no idea what any of that stuff means. So how about we just say that there's a switch that turns on and off that basically causes the ignition coil to build up and release a spark when it turns off. So in other words, the switch turns on, coil builds up, switch turns off, it releases everything inside the coil and creates a spark. How's that?
I like that. Yeah, and sometimes I forget using big terms.
Like I said, you're getting all Einstein on me. But all we're looking for is my truck is not starting. It doesn't have spark. What kind of test can I do to fix my truck, or find out, better yet, find out what's going on with my truck so I can go into the parts store and buy the right part?
Okay, rule number 1, Ford TFI ignitions. Now, in this case, the module is actually on the firewall, and a lot of these are actually on the distributor. But whether it be on the distributor or on the firewall, rule number 1 would be the top wire is the crankshaft sensor or distributor pickup wire. Now, I know.
So that's the signal coming from the distributor as it spins around to turn its primary circuit, the switch that turns the coil on and off.
Correct.
On and off. That's the wire right there that does that?
Yes.
Okay, cool.
And Ford calls that the PIP wire.
PIP wire.
PIP stands for Profile Ignition Pickup. Ford's got to be goofy with their names. You know, they always kind of were, but...
Okay, TFI stands for thick film integrated.
Thick film integrated.
Ah, I knew that.
Yeah, TFI. I mean, whatever. It's an ignition module, right?
All right, so it's a switch, basically, is what it is.
That's a switch input right there, and so we're
that's where it comes from. That comes from the engine. It tells that thing to switch the coil on and off, and
That's
that
right.
signal wire is coming in. That top wire right there.
Yep.
What color is that?
Hard to tell on some of these older ones. It looks like that is. It's got an orange stripe, maybe tan with an orange stripe. I mean, discoloration is common.
All right, so I'm not going to hold you to that.
No, don't hold me to that.
We're just going to say the top wire there.
It actually could be light blue with an orange. I'm not sure.
We'll call it the top wire.
Top wire, and I've done that over the years, and it's always been the top wire. Now sometimes these can be mounted in the other direction. No, it'd still be the top wire no matter what.
Okay, so we're looking for the top wire on the ignition module there, and what are we going to do with that top wire?
We're just going to back probe it and get a voltage reading off of it.
And what's that going to tell us? Is that going to tell us if that switch inside the distributor is working, or what?
Well, a couple things. One would be wiring integrity, and 2 would be mainly the Hall effect or the signal from the distributor. We're looking for that signal in this top wire.
And if we're not seeing that signal from the distributor, then it could mean either the wiring or the thing inside the distributor that sends a signal to that ignition module is not working.
Correct.
Awesome. How do we do that?
Okay, let me grab my multimeter.
Okay, so now we've made the determination that the ignition coil is not firing, and we're going to take a look at the ignition module. What tools would be good to use for something like this?
Well, I mean, we could use a test light.
Okay.
Test light, and you know the test light method of looking for pulsing on coil negative.
Got a Honda video about that very thing.
It is a great test. I like that test a lot. We can go that direction, and you know, if we have pulsing, you know how it goes. We have a coil issue, no pulsing, there's a control issue. And we just kind of bypassed a step. We're going right after the input first, even though we didn't do that. And that's the nice thing about diagnostic work, is really isn't one right way to do
But
something.
it is a good idea to actually do the diagnostic work, so you don't really make the parts guy mad when you take back the part that he gave you to fix the car.
For sure.
They don't like taking electric parts
No.
back. All right, so show me what you got here.
Just an old school multimeter. This is I don't even remember how long I've had this meter.
You can pick these things up for like $10 these
Yeah,
days.
you really can.
And what do you got it set on?
I have it on DC volts, and I'm going to hit actually it's on an auto range. I really don't like an auto range, mainly because of changing signals it'll beep and mainly be annoying in this video. So, so DC volts, I have no alligator clip on my grounds. One of the things I always tell my students, it's very important that once you have a ground location, that it's a stable ground and stays a ground. So I like to use an alligator clip, and I don't have one, so I'm just using a jumper wire. And what I found is brake lines actually make very good grounds for the most part. Certainly you want to go to battery negative whenever possible, but when you're doing a quick test like this, I think it's okay to just pick something. But certainly we want to make sure that our meter reads before we would even do this test. I want to go over to battery positive and touch this. And really I'm not checking my meter, I'm just making sure that my ground connection's good so I can rely on the reading that I get when I check this module.
And just a quick tip for everybody. As far as like the way voltage works on a car, there's a power and there's a ground to everything. So there's always a loop, and it always begins and ends at the battery. but pretty much anything metal on the car becomes part of the ground system. That's why hooking that up to the brake line works. And if we're going to check the voltage on something, you can use your 1 lead to actually check the voltage that's there, and then the ground is pretty much anything metal that's on or near the engine or on the body of the car.
So just taking this multimeter, and we want to, our main issue here is that this reads battery voltage when we check, and it's high because I had it on a charger today, so I'm okay with that. 12.8 volts. My main issue, that is a good ground location, and whatever reading I get at that ignition module, I can be confident that I have a good ground.
So cool. This is not a fancy scope or anything like that. It's just your average voltmeter.
That's right.
Awesome. So now we know that we actually have a good ground connection and that we're going to be getting as accurate a reading as we need to get for something like this.
Yep. Just back probing this. Certainly we can use a T-pin, but I don't have an alligator clip on that end, so it was just helpful to...
Yeah, I have like a set of stick pins that I often use for something like this.
Yeah.
So basically what you did was you went right in the back of that cavity where that wire is.
Yep.
You got your ground hooked up here on the master cylinder, and then we're going to look at the reading here as you crank the engine.
I'm going to turn the key on first.
Okay.
And see what we have key on.
Okay. 1.32
That's interesting.
for whatever that means.
Didn't expect to see that. I thought it'd be higher, so that might...
Last time I was here, you were seeing things you weren't expecting.
Yeah. I actually might have an issue with this connection, but we'll see what we have.
It looked a little green.
Yeah, I did. So we have 10 volts on that wire, and that's
a little more reasonable.
Yeah.
So we want to make sure that we have a good connection down there when we're back probing something. So we might want to wiggle that around if we're seeing something not expected.
I would say it's probably the two most common things I see my students do would be have a bad ground connection, number one, and number two, not be making contact with the pin or wire that they're trying to test.
Okay. But you can't get so brutal that you're in there like messing up the back of the connector, because you can't actually cause a problem during your diagnosis. So you got to be careful of that too, don't you?
Yeah.
Okay. So seeing that 10 volts, how, where are we at?
Well, what we want to see, that would be the top end of this on-off crank signal. And what it should be is a 0 to 10 volt signal. And so I'm going to crank it, and we're going to look for an average of that. Okay. Multimeters, they just aren't fast enough to pick up.
It's not a lap scope, so it's not going to do your thing. But
we're talking about maybe, what's one distributor rotation, that's every 720 of the crank. Point being, there's going to be a lot of signals occurring in a small period of time.
And that's not a fast meter.
And that isn't fast enough to pick it up.
So what are we looking for since it isn't fast enough? Are we looking for it to change at all?
Yes.
Or are we looking for, if we see no change, what would that indicate?
If we see no change, that's going to put us on the track that this has a crank sensor problem or a distributor pickup problem.
Okay, and if we do see a signal?
If we do see a signal, then that's going to put us toward this ignition module as potentially being the fault.
Okay. Well, you crank and I'll look.
Or the other one would be the coil too, and that's where that test light test maybe would have been a good place to start too. And we're not wrong in going this direction. We may end up having to do that at the end if we find that this signal's good. That I think maybe the next thing would be to see if that coil has control or not, and we could have a bad coil or a bad module. But this test is going to be, we're either going to go towards toward the input as a problem, or we're going to go toward the outputs as a problem. That's really what this test is doing.
Okay, cool. You crank and I'll look.
Okay.
It kind of went all over the place. It went down to like 8 volts, 9 volts, and now it didn't come back up to the 10 we were expecting. It's close, but...
Did it go any lower than the 8 volts?
No, it looked like 8 was like the lowest that went.
My concern with this test would be if you heard the sound of the starter, it sure sounded like this battery is weak. Even though we had 12.8 over there, it wouldn't be a bad idea to get a battery voltage reading, but I truly believe that the low voltage you saw was because system voltage was dropping to a level that indicates this battery's weak.
Okay. Well, I'll buy that, but still at the same time, we did see some switching there.
Yeah. Well, what you'll see on a good one, though, you'll see 4 to 5 volts on one of these.
Oh, really?
Yes.
So that was much too high.
Yes. And I think really what you would see if this, we could redo it if you want. I'll put a battery charger on it. I really think that probably would be a good idea. It's up to you, but
Well, if it showed 9 volts and we're looking for 4 volts, how would that actually...
We're looking for 4 to 5. Yeah, and so...
How would putting a battery charger on there actually help us?
Well, what's going to happen is we're going to bring system voltage up higher, and what you'll probably see is this will maintain 10 volts the whole time we're cranking. And I'm saying the reason why we saw some lower voltage was overall system voltage was dropping, and that was causing that.
But how does this help me figure out my no start? if I only saw it drop into like 9 volts,
Well,
and it was a system, it's
okay.
a system voltage issue.
Yes.
Whereas I'm expecting to see 4 volts.
Well, what this is telling us is that there's no crank signal here.
Okay.
And it's, you know, truthfully,
But if there was a crank signal, I'd be seeing it going down towards like 4 or
4
whatever.
to 5, yes. Okay. That's correct. And you know, we're only talking about, you know, 4 or 5 volt difference on making a call here. And I think you can see why I'm so biased towards a scope. I mean, because I want to see
Stop it, Einstein.
I know, but I want to see this issue. And this test works, though. You can use it. And I'm going to show you another test, actually, that's going to back this up that says there is no crank signal here. And this is what I used to do. So this test is great, but I still think it does leave some questions. You know, you're not 100%.
So what's your other test?
Okay, the other test is going to be, well, before we do that, just to address, because we did have 12.8 volts at the battery, saying the battery was fully charged. That was a surface charge. Just keep that in mind. We just took it off of a charger. Just because you have 12.8 on a battery doesn't mean that that battery's doing what it should be doing under load. In any case.
I'll give you that.
Next test we're going to do is actually we're going to create the signal that this crank sensor makes, and we're going to send it to this module and see if the ignition module reacts to this signal.
Okay. How are we going to do that?
We're going to use a test light, and we're going to actually take that 10 volt signal and we're going to pull it to ground. That's what the Hall effect does inside of this distributor. Is it's going to take that 10 volts, switch it on and off to ground to make the square wave.
So we are going to become the switch. We're going to take it out of the switch inside the distributor that's supposed to do this. So we're going to take that out of there, and we're going to see if we can produce a spark based on what you're doing here.
That is correct.
Okay, cool.
So I'm going to use a brake line again for a ground, and I'm actually going to leave the voltmeter on there so you can see the drop. And I might have to get a.
So what are you doing? You're just touching like the,
I'm
the
gonna
end of your test?
just gonna touch the end of that, but I think what I'm gonna need to do is I'm gonna need to put a T-pin in there so I can do both at the same time and show that.
Okay. Okay. So you put a T-pin down in there.
Yes.
All right.
And I'm
Now
just.
you're gonna put your.
I'm actually gonna put the multimeter lead back in too. This is actually a big enough connector that I can do both.
Okay.
You see the T-pins on there, multimeters there. Still have 10 volts on our multimeter up here. And I'm just going to take this test light now, and I'm going to touch it on and off. And you should actually move your left elbow over next to that, and I could shock
Okay,
you in the camera at the same time.
Awesome. I love working with you.
All right, so
hang on a minute.
Yep.
Let me come over here. I'll show you. Show what you're going to touch. I actually hear it happening. All right. Go ahead. So you have now become the switch that's inside the distributor with that test light.
That is correct.
Let me ask you something. Can you really use that test light, or could you just use like a jumper wire?
You could use a jumper wire in this case, but I want to be clear on this test, because I do this type of bypass testing a lot, and certainly it's raised some eyebrows in my field, in our field.
Okay.
I've raised some eyebrows doing this kind of stuff. The reason I choose to do with a test light is in case I touch the wrong wire. If you use a jumper wire, there's really there's protection in there, and the bulb actually has resistance and is kind of your safety oops in case you touch the wrong wire. That'd be the main reason.
Okay.
In this case, I can definitely use a jumper wire because of circuit design, and that would be critical. You would need to know and be confident of circuit design.
So it's not like we're using like this on a 5-volt signal. This is an actual 12-volt.
Correct. And even a 5-volt, if it was a 5-volt, what I would call pull down, meaning it switches to ground, you could certainly still use a jumper wire even on a 5-volt.
Okay. But basically, you're becoming the switch. You're using this test light because that's sort of like your safety feature, so that in case you touch the wrong wire, you won't fry that module or fry something else in the system.
That's correct.
Okay, so that's why you use that instead of, like, say, just a straight-up jumper wire.
Yes.
But you could use a straight-up jumper wire, but we're not going to encourage that behavior.
Correct.
Cool. Go ahead, do it, Frankenstein.
Okay.
All right, now, something you made mention of just a moment ago when you were using that test light in order to create that signal to send over there was that I cannot use an LED test light. Why is that?
LED test lights have very high resistance, and they're actually very safe tools for checking computer circuits, which is why they made them that way. But an LED test light for the test that I'm trying to do, which is pull a circuit to ground, doesn't have the amount of current flow through it. It has too much resistance and it won't work.
So show me. Show me what happens when you try to use a digital.
So touch the LED test light on here. It actually lights the bulb, unlike the regular test light. and touching it on and off. There is no triggering taking place on our spark tester or our coil.
Nothing at all.
And I use my conventional test light with an incandescent bulb. One of the things the light does not light.
Well, look at that. You do.
And we trigger it. And so to answer why the light doesn't light even though there's 10 volts there, is it's not 10 volts that's going straight to a battery source. There's a resistor inside of there. So when you touch this test light on there, it's pulling it all to ground. There's nothing there to light the bulb.
Can I just make it simple? Digital test lights aren't going to work to do this.
Yes.
Just regular bulb type test lights are going to work.
Yes, I like that. And you know, we don't want to throw these out. These LED test lights are nice, but if you're going to do the bypass test, you got to use a regular test light. You can actually hear the fuel pump running too, because what we're doing is we're sending an RPM signal to the engine computer too. So this is your RPM signal.
Awesome.
And this test tells you that the module is good. There's really no reason to check powers and grounds on the module. If you had a power and ground problem on the module,
You wouldn't get a spark.
exactly. The other thing too is it tells you the coil's good. So we've kind of eliminated the whole system.
Yep.
Other than the crank sensor in the distributor, using a voltmeter and a test light.
So at this point, you would say it is that crank sensor based on what you're seeing?
I would. And I mean, you would want to go a little bit further and make sure you have a good power and ground at that crank sensor, you know, because a Hall effect needs a good power and ground to do, but, you know, without getting too technical.
So like say for instance we go in there and we find that that crank sensor connector has a bunch of like green yuck in there.
Yes.
Something like that. Or some other part of the sensor might be all full of corrosion or something like that, then we can reasonably assume that it's the sensor and not say a connector or wiring problem.
Yes.
Cool.
One other thing too would be, you know, depending on the car, make sure you don't have a broken timing belt, timing chain. That if that distributor is not turning,
exactly, you won't get a signal.
Yes.
Yeah, if the engine's not turning, you won't get a signal. Cool. And an easy test for that is just to pull that distributor cap off and watch the rotor spin.
Take a look, crank it over, make sure it's spinning. But I think one of the things we can do that would just save time for this is we can substitute a switch.
Unknown good.
And I can show you actually without pulling the distributor apart and showing all that, we can put a crank sensor in this and I can trigger it manually to show you that this is in fact our problem.
Ooh, cool. So you show me how the actual switch works?
Yes.
Do it. Okay, so where are we now? We're down. You're down coming off of the distributor. You got yourself a connector there that you're disconnecting. And that is the connector for that Hall effect sensor?
Yes.
Okay.
And actually here's the new piece.
Good.
Yeah, and this one.
At least it's not dirty.
Yeah, this one, you know, they sell the whole distributor, or they sell just the pickup. Certainly the distributor's got to come apart to change this.
Right.
But what we're going to do is, and this is actually the piece that the blades travel through. This will be your Hall effect unit. Right here would be the Hall element. Right here would be the magnet. And then you're going to have a piece of iron, magnetic, ferrous material that's going to move through that and block that magnet from contacting this, and that's what does the switching.
That's your switch. Okay. So basically we can plug that in and run a piece of metal back and forth through there and be that signal?
But I'm pretty sure I need to ground that too. There's a ground tab, so I'm going to have to plug this in and run a jumper to that, because that would be the ground location.
You got a jumper right there already.
I do. We'll use that jumper.
Cool. All right.
I'm going to go get a piece of metal.
All right.
You know what's funny is this piece of metal I grabbed, this is a Subaru igniter.
Subarus are awesome.
We're going to trigger a Ford Hall effect with a Subaru igniter.
I like the way you think, man.
All right, so key I think needs to be on.
All right.
Key is on.
Here, see if we can hold that up so I can see the spark and that at the same time. Oh, that is ideal. All right, I'm going to hold this away.
You ready?
Go ahead.
So what we're going to do with this part, we're just going to pretend like this is the trigger inside of the distributor. And as I block that magnet.
That is so cool.
And so what that confirms for us is we made the right call, and this, when we put this pickup in this distributor, this truck's going to run. Well, it's at least going to have spark.
Well, yeah. We'll at least solve one of its problems.
So that's a pretty neat test.
That's a way neat test. Love it. ScannerDanner without a scanner.
Eric the car guy.
With a camera.
With a camera.
To catch it all on tape. So yes, you can fix things like this without expensive scanners. You can just use a regular DVOM and a test light and a jumper wire, and you have valid testing for the ignition system on this here Ford. which we were able to determine the signal from the distributor was not being sent to the module that fires the coil. So this distributor pickup inside there was not sending the switch signal to switch the
Thingy?
The thingy under the, that thing.
Yeah.
Sending the signal back.
We
and
got
forth.
it.
They weren't talking to each other.
Yeah.
Yeah. They were not communicating.
Nope.
See, communication is key to the operation of the ignition system on a Ford. Is that?
For sure.
Would that be fair to say?
I think so.
Okay, but so we can use just these rudimentary tools to find out if we're getting a crank signal or not, and also we can make our own crank signal by just taking a piece of metal and putting it through a new sensor, which I thought was like a cool trick.
That is cool.
I thought that was a very cool trick.
Yeah.
Oh, we can't forget about our spark tester that we also use. All right, getting back to what we're supposed to be doing, which is showing you how to solve a no-start problem if your Ford truck does not have a spark. Well, this might be how you might go about it to find out what parts you need. Eric the Car Guy, ScannerDanner. You can find me on Google+, Facebook, Twitter. You can find him at ScannerDanner's channel. He's also got, yes, and I'll put a link in the description to that so that you can find him in all of his wonderful videos that, they're, like I said, Einstein. He was getting all Einstein on me.
Sorry, I tried to dumb it down as much as I could.
Well, that's why I'm here. Anyway, Eric the Car Guy, be safe, have fun, stay dirty. See you next time.
Awesome.
Take care, man.